Hi, my name's John, and this is the first part in a multi-part series about Bazel. And my intent here is to, kind of tell you a little bit about what Bazel is, and then in the subsequent videos that I'm going to post into my YouTube, we'll get into actually actual what does Bazel feel like? How do you set it up? What are the main commands? And maybe what is an average developer doing when they're going through the life cycle of using Bazel? And as a side note, I am the founder of lowtouchadvisor.com, where we have senior Bazel engineers who are available to join your Slack channel to help you on your Bazel journey. So if you're interested in maybe getting a little bit of Bazel help, come see us at lowtouchadvisor.com. Okay, so the first thing I'd like to do is talk about what do I wish I had known when I started my Bazel journey. Now, it's recording this in the year 2026, and I just finished 2 years of working on Bazel personally, and I went from not knowing at all to being 2 years in and had kind of got fairly deep into the weeds, let's say, and let me first start by saying that if you're on a small team or a small project or working on an app that only has one language, you do not need this. You could probably just end this video right now and move on with your life. This is a tool that becomes more interesting the bigger a software project gets, but especially as the software project might have multiple languages, or you're considering a good tool that works well with a mono repo pattern, and something that might build and test things quickly, and what else? And that's also hermetic, and I'll kind of unpack what each of these things mean. But at its core, what Bazel is doing is it sort of sits in front of the language idiomatic build tool, right? So let's think of when you're a Go engineer, you install the Go tools at a certain version, and then when you want to do a build, it's Go build or it's Go test. Rust has its own way of doing things if you were programming in Rust. Or if you're a Python engineer, right? You're going to download a certain version of Python at some particular version that your project needs, and then you're typing Python commands to run tests and to maybe build. Well, that's kind of funny because Python doesn't compile, but we can get more into that. But the beauty of this, I'd say the primary reason why someone would even use this at all is because you're trying to have one way of doing things, given that there's multiple languages. Like, how do you solve for that? In my journey before going into Bazel, I was looking at, and I've been part of companies where there were a lot of repos, right? There might be hundreds of repos where everything's done a little bit differently. And you want to work in this project and you need to know, oh, we need to get, Golang at a certain, language version, and the tools need to be arranged in this way. And then, oh, over here, it's a Python project. Well, we need a very specific version of Python. And then for Rust, like, you need to type this command to get the thing to build or to test, right? So there's like a lot of cognitive load that you need to do, and you need to like clone all these different repos in order to be able to work because it's microservices, right? That's the sort of way that people have been living for a long time. And they're probably to this day, you might be a person who's working at a company where it's like, oh, you're doing microservices. We have a service mesh and there's protobufs and that sort of stuff. So we're doing the most advanced thing, right? But when you hit there's a certain limit, and it's probably different for everyone, where you'll get to a point where you realize this is not working out anymore. You might have thousands of Git repos. How are you supposed to manage that? How someone might say like, oh, at your company, how do you guys do builds? How do you do testing? How do you make sure the software is valid before you go to deploy it? Well, we do it about 1,000 different ways. You're like, what kind of position is that to be in? So the Bazel way is one in which you all agree that we're going to consolidate. I mean, this is usually what you would see. You can do whatever you want in life, but a typical use case would be that the team agrees that the company's growing, that you're going to be using multiple languages, and you really want to have a single way that you do your builds and your tests and maybe how you run some of the software. In this world, when you have a Golang engineer over here and maybe a Rust engineer over here, the Golang engineer and the Rust engineer are typing the same commands to do these activities, building and testing and running. So you don't need to know anything about, like, Golang guy doesn't need to know anything about what the Rust lady how they set it up. It's just the Bazel commands actually trigger the building and the testing. It's the same commands no matter what language we're dealing with. That's pretty cool. Another thing that's pretty cool is that Bazel will go and actually get the tools for you. So imagine, I'm a Go engineer and I want to make sure that the Rust code is building or it's testing. I could just more or less type, Bazel test, and then I give like a reference to the thing I want to have it test, which might be in Rust. Bazel will go and is able to detect, oh, I don't have the Rust tools available on this system, and it'll go and get them, and it'll use them. And it will install them into a Bazel sandbox so that it doesn't like taint the host machine. So that's pretty neat. In companies that don't do this sort of thing, you have to have a bunch of readmes or bash scripts or something like that that go and get all the tools and at the right version. And let's say, for example, someone introduces a new version of a language. We're going to use the next version of Python, and everybody has to go and like manually update their systems to be working on that with that version of Python. That's not how it works in Bazel. In Bazel, that would be a one-line change. Someone would say like, oh, there's a config file that says this is the version of Python. When the next time somebody git pulls and they pull in that change, Bazel will go and get the version of Python that's the right one. And it also allows for everything in your code base to kind of depend on other things in a really nifty way. So let me give you a random example. A few years ago, we had that big Log4j crisis, right? A bad version of Log4j went out was announced, and everybody scrambled to go and update their Log4j. But the Bazel way this sort of problem would be addressed is that Log4j would be defined as a library in your Bazel configuration. And there would be like a Log4j, there would be one file that says this is the version of Log4j we're using. Imagine then someone goes in and they just update maybe one line to say, we now want to use this newer version of Log4j. And then you open a pull request, and then all of the code that uses Log4j, it gets rebuilt and shipped out to where it needs to go. That's what we're talking about when we're dealing with Bazel. So it's like an entire way of working. But it's like a big decision. I mean, this is a complicated tool. Imagine the difference between running Docker on your host machine, how simple that is. You just do whatever you want. You use whatever tools you want, and that's how a lot of us learn. We just kind of do whatever we want on our local machine. But that doesn't scale. What if your project has 100,000 tests and multiple languages? Like, that's a kind of a big problem, and a lot of tech companies get to a size where they're doing that kind of thing. One of the things Bazel has built in is the ability to remotely build and execute your code. So let's imagine a code base that has 1 million tests. Bazel has a way that you can configure that will cause the build or the test stuff to happen in a remote execution environment. So imagine like all the tests are split up into individual pieces, and then they're all run in parallel through a remote execution farm. And it all builds, or all the tests run, all 1 million of your tests all run, and then the results are consolidated and they're presented into the caller's terminal session in the same way as if they had run locally, except for that it ran much faster because you really leverage the ability to take advantage of that remote execution. Pretty cool. And because it's like Bazel's kind of discreetly kind of obfuscating, for the ordinary person, like how it's doing its thing, means that, like, imagine a CI pipeline, for example. You might see something that does Bazel test and then, the Bazel wildcard symbol, and it would just test everything. And it would go and get all the tools it needs in CI. You wouldn't have to go and pre-arrange to have all the right tools installed. Bazel gets them for you. Like, this is pretty cool stuff. But it comes at a cost. It's just like Kubernetes, right? You have local Docker development, easy. But then if someone were to say, like, how complicated is it to set up Kubernetes? It's pretty hard. I mean, tech companies have entire teams, infrastructure teams, that are just like the Kubernetes team. They set it up, and they're the expert in Kubernetes. It's like, that's a complicated tool that is like, there's a right time and place for Kubernetes. But when you're smaller, you probably wouldn't set up your own Kubernetes support team anyway. I realize there's hosted Kubernetes that try to make it simpler, but Bazel is a complicated tool, and there's a time and place for it, and it's up for you and your team to decide if it makes sense for you. Couple of other comments I'll make when you look through the rationale for using Bazel. One of the really cool ones is it's very hermetic. It supports like in all of its nooks and crannies the ability to be hermetic, which just means that if you build a version of your code on Monday, and then on Tuesday you come in and you didn't change anything, and you do the build again, it's going to build and be exactly the same as it was the day before. But without something like Bazel, it's very common that you might try to come in and have you ever done like a Docker build on Monday, and then the next day you do the same exact Docker build and it doesn't work anymore? Why? Oh, because some random thing somewhere out on the internet changed. Somebody had like a curl command in their Docker file, and it did some request to some third-party thing, and that third-party thing has changed. So, Bazel is designed to avoid that sort of problem. You can do things the wrong way, just like you can drive a car into a tree, right? But Bazel's, with a seatbelt on, you can get into trouble driving a car. You can still use Bazel the wrong way, but it's designed, in its design, in its DNA. You'll find it as you get into things that everything is checksummed, and everything is because everything is like hermetic. Like things get built, they get checksummed, and then they get registered in cache, so that when you're doing something, you wouldn't, like when you're building something, let's say, you won't ever need to build something that's been built previously, because you're always able to leverage all the other stuff that's been built, and say Bazel will say like, oh, this thing that you're trying to build, someone else has built that exact thing before, and they can download it from cache, and you benefit, you profit. So Bazel has local caching, Bazel has remote caching that multiple people or machines can use, and there's a bazillion ways to set it up. So yeah, the idea that it's hermetic is neat. We talked about caching, we talked about parallel. And the last thing I'll talk about is that it's extensible through this thing called rules. So when you get Bazel for the first time, you install it, it's fairly, lightweight, let's say, for lack of a better term, and you pull in the elements of the Bazel things from the community that you need. And that's what they call rules. So if you are writing a Go app, you're going to need, in Bazel parlance, the Go rules. If you're working on a Rust app, you're going to need the Rust rules, and so on and so forth. It just goes on and on. But the point is that Bazel, for all intents and purposes, supports all languages. That would be fair to say. Maybe it supports some better than others. For example, the Golang rules are really well supported. The Python rules, it's getting there. Python's kind of funky because Python doesn't compile. But at the end of the day, this is a tool that provides a consistent pattern for building and testing and running your code. So that is my overview. And I'll just remind you that at lowtouchadvisor.com, we have senior Bazel engineers who are available to join your Slack and help you on your Bazel journey, and they'll be there all month long. And you can just have a Slack Connect channel or Microsoft Teams where our senior Bazel engineers can help you. So thanks, and take a look at my additional videos I'll be posting in which we install Bazel and actually try some of the typical Bazel workflows. All right, thank you.